The theory and practice of teleportation. The reason I picked this subject is I was pretty sure a bunch of MIT students would be out there, and I don't want them to catch me at anything, and they probably can't with this. Before I go into this, I'd like to ask for. Does this thing work? Yeah, this is fine. Good. Now I can shout louder than Lester Del Rey. I'd like to ask for volunteers from the audience to help me demonstrate teleportation. Is anyone out there a teleport? Teleports only, please. Oh, you? Okay, jot up here. No, don't walk. Don't walk. Don't walk. If you have to walk, there's no point. I can see you, yeah. I'm up here. Oh, yeah. No, that's bilocation. Teleportation, well, I'll get to that. Where am I? Oh, yeah. Working definition of teleportation. Just for kicks, we'll call teleportation any method of moving from point to point in negligible time. Over short distances, we'll take light speed as negligible. Over longer distances, infinite speed. I'd like to make a distinction between psychic teleportation and mechanical teleportation. With psi, essentially you wish yourself from place to place. With mechanical teleportation, you push a button. You may do some things first, like sighting in, focusing, whatever, but eventually you're going to push a button here and you're going to be there. Okay. This may not be a rigorous definition, but intuitively it's good enough. Intuitively, you all know what teleportation is anyway. I'll do a little bit on the history of teleportation, and that, of course, is all psychic. Historically, the prophet Elijah, who was apparently, have I got the right prophet there? Transported by Jehovah, frequently he would rise into the air, spin around a few times and vanish, or would not vanish. He'd fly around and not vanish. Eventually he flew up, and nobody ever found him. They searched the whole country for his body and never found it, so they assumed he rose into heaven. There was another Friar Josef of Cupertino, 1603 to 1663. He was a levitator, but which is where he got his reputation by. He'd go into a trance and fly around, landing in trees and so on. And he also had the power of bilocation, which is what I was talking about a moment ago, being in two places at the same time. I'm going to ignore these because these are not teleportation. Teleportation is being in two places at different times. The interesting thing about teleportation in history is nobody seems to make any distinction between teleportation, flying by flapping your arms, flying by holding your arms still, being in two places at the same time, or being blown around by some unknown force. I offer to you that there may be no distinction, that this may be one of the things about teleportation, but I'm dealing only with teleportation. And I'm going to be talking mainly about mechanical teleportation. I'll dispose of psi fairly quickly. And I'll be talking about the effects of teleportation on society. First, there's a theory I've run across twice. There may be other examples. A man in deadly danger would learn to teleport. Jack of Eagles is one example. The Star is My Destination by Alfred Bester is another. This is how a man learns to teleport. Somebody points a gun at his head and fires, and he has to teleport out of the way of the bullet, or else. I think we can scotch this thing. There's just been too much opportunity for it. Let's face it. let's face it, unless you're going to die of old age or disease, you are going to teleport. You're going to learn how. But there's something else, too. John W. Campbell isn't here, is he? Ask John W. Campbell. He'll tell you. He'll tell you at great length. Psychic powers are notoriously undependable. The time when the ability to teleport is most needed, that's the last time you'd expect to see it. I have a prejudice against psychic teleportation, and here's another reason. We haven't seen it around. There's been science on this planet for, depending on where you start it, 4 centuries, 2 millennia, 1 century, or 50 years, something like that. But psychic powers have been either don't exist at all or have been around as long as we have been definably human. We should have been, if teleportation is both possible and useful, we should have been using it for a long time. We conclude that either teleportation is impossible, or teleportation is impossible to all but a favored few, like 3 per generation, and all 3 of them a little nuts up here so that nobody believes them, or teleportation is a liability to those who possess it. I'll cite the Blue Jaunt of Bester's The Star's My Destination. Imagine a man in a panic learns to teleport to get out of the way of a bullet and winds up inside a wall. Boom. I'll mention this, but get to it in depth later. How about conservation of energy? And how about conservation of momentum? Can you teleport uphill? And if you can, will your body get colder or what? The energy has to come from somewhere. If you teleport halfway across the world, will you wind up with your velocity change so that you'll smash into a wall? Because the Earth is rotating and the back side of it is going in the opposite direction from the front side, whichever you define as the front side. These are problems if you're going to experiment with teleportation. Ethically, I suppose I shouldn't have asked for a volunteer, because it's dangerous, there's no doubt about it. I'll mention a theory of psychic teleportation from the world of Null A. It seems that 2 objects similar to each other to 20 decimal places will join each other. The lesser will bridge space to contact the greater. This applies to matter, it applies to mental waves and thoughts and personalities too. The delay in teleportation decreases with greater similarity. This is the theory from the world of Null A by whoever A.E. Van Vogt. We can't disprove this. It could be true. We can't disprove it because he doesn't define similarity, he doesn't define lesser, he doesn't define greater. So this is the way to write a science fiction story, in case you were wondering. But Van Vogt missed some great comic routines, I think. Let me visualize one for you. We got Gilbert Gossine in The Pawns of Null A. He's on one side of a fence and he wants to be on the other, and the fence is too tall to walk over. He looks at a piece of land just beyond the fence, and he thinks at it, and he visualizes it, and he's got it all straightened out. So he adjusts himself so that he will be similar to the plot of land, and he will be the lesser and transform there. Now, 20 decimal places is pretty tiny. Let's face it, to make sure that he's within 20 decimal places of this, of being similar to this plot of land, that's one thing. But he also has to be sure that he's the lesser. The comic routine I've got in mind is when he finally makes the bridge, you know, and 20 tons of earth fall on his head. Okay. Like I said, dangerous. Okay, let's. I've in my own mind fairly well scotched the idea that psychic teleportation is both possible and desirable. But let's forget about that and assume it is both. We'll assume that it's possible for nearly anyone to learn to teleport. There's a new learning technique. I don't know what it is. It may deal with shoving DNA molecules or RNA molecules into your food and tailoring them so that they carry a memory, as in the system we've got now of feeding flatworms to each other so they learn fast. What do you get with this new learning technique so that everybody is a teleport? You get The Stars by Destination by Alfred Bester, pure and simple. I offer that as a textbook to go with this lecture course of mine. I'll name a few of the things you get. You get uncatchable thieves, uncatchable or nearly uncatchable, who teleport around on Earth's night side and who never see the sun. If you ever see one of these guys, he will probably be dead white. You get complex mazes not to replace locks. You get them to add to locks. You've got a locked door, and then beyond it, a maze big enough to confuse anybody and tricky enough to confuse anybody, because otherwise anybody and his brother can teleport right into your home. You get classification of your ability to teleport, jaunt status C, D, transport vehicles become totally obsolete. And I put a question mark here, my own idea. Is the distance limitation in The Stars My Destination due to relativistic uncertainty? Because the further away the thing is, the less sure you are when it is happening? That's my own question. Anybody who wants to try to figure it out and do the math is welcome. I have an objection too to Gully Foyle's ability to follow a geodesic. If he does this, he's going to wind up moving at light speed or less, because that's how geodesics work in relativistic space. But that has nothing to do with the society as Bester outlined it. And as Bester outlined it, it's perfect. I think he foresaw everything. I'm going to go from psi to mechanical teleportation. And first I'm going to talk about the theory. Anybody know anything about tunnel diodes? I read a story by somebody named Smith. There are too many Smiths around, and too many Smiths who write well. I can't tell them apart, but there was a guy who wrote about a teleportation system based on the tunnel diode effect, which takes an electron here and puts it there without its crossing the intervening space. He postulated a system that would do that with human beings. That's one not too well used theory. The way that is best used is the traditional way. What you do is you put your human being in a box, and you either convert him to electronic waves, electromagnetic waves, fire him across space, catch all the electromagnetic waves in a receiver, and turn it back into matter. That's the traditional way. A modification of that is Poul Anderson's method in the Enemy Stars, published in England as We Have Fed Our Sea. What he does is he's got a system that records the position and energy state of every subatomic particle in a human body. Unfortunately, he has to wipe out the human body completely in order to record it this way. And he winds up with a plasma gas that gets sucked down through a grid, ready for the next incoming object. He now has a signal which he fires across space, only he fires it instantaneously. Receiver picks it up and uses the ionized plasma in its box to reconstruct the human being. About this method, I will say that I wouldn't ride one of the goddamn things. What happens to your soul, if any? Does anybody here believe in a soul? I'm not sure whether I do or not, but obviously it better be recorded. somewhere. But there are other objections to this, as far as society is concerned. You've recorded your human beings, say. You've recorded Isaac Asimov, and there he is on tape. What's wrong with firing him at 2 receivers? Now you've got 2 Isaac Asimovs. Yeah. All right, it isn't all bad. But, okay, here, another thought. Understand, these are not new ideas. I've gotten them out of science fiction stories read since I was 12. Why destroy the model? Obviously, you have to do it with Poole Anderson's assumptions, but there may be an improved way to do it that would leave the model intact. You fire the signal of Asimov at Mars, and you got Asimov here too, which is fine. Also, you could record the. You can just keep the tape. Don't fire it anywhere. Then 10 years from now, Asimov wanders in front of a bus. You recreate him from the tape. Here's a problem. Well, the least little bit of interference with this signal gives you a mirror image Asimov, or an Asimov with 2 arms out here. You got to make sure you get everything strictly correct. Okay, that's a wee bit of interference. I'm not going to name all my sources. I can't remember the stories that I picked all this from. Most of it is not original. There's a thing called teletransposition, or transposition, and it's better than teleportation of this method. I'm going to call them both teleportation, just so I won't have to foul up the speech. It's the way I typed it. Teletransposition is you make 2 spaces contiguous somehow. You take advantage of the, quote, fact, unquote, that the universe resembles a crumpled handkerchief with spaces contiguous that don't look contiguous when you look along the apparent plane, hyperplane. If the universe doesn't resemble a crumpled handkerchief, then maybe you can make it resemble a crumpled handkerchief by... Now here we go.
Go ahead, talk.
Yeah, I want you to look over there. That's a copy I made just before I started this speech.
Any girl volunteer to come up and kiss me and test the excellence of the copy?
Do it. I took great care with this model.
Oh, I didn't know she was in the audience.
I think I called up his eye. I tried to improve the...
So is she, both of them.
You are the copy, aren't you?
Pardon me?
You are the copy?
Yes, I can do this over and over and over and over.
Oh.
Again for the picture.
Whoops.
She's got a nice together event right next to the Star of David. Okay, let Larry speak.
Okay. Now, I said I was going to talk mainly about the effects of teleportation on society. I am. I'm going to try and show you that any limitation, that the limitations you assume for your teleportation are going to define a society. Any set of limitations is going to define a different society. Again, I'm not going to quote my sources. I'm going to quote a few because I typed them out here and I don't have to remember them. Assume you don't need a transmitter. You've got a receiver that will teleport anything to your receiver from anywhere. Okay, now you can steal anything at all. The Skylark of Space and a few sequels assumed machinery that could do this, and assumed that Duquesne had them shortly after the hero had them. I remember the hero. I don't remember the hero's name. All I remember is Duquesne. Okay, Seton. Shortly after Seton developed the ability to steal anything, Duquesne developed the ability to steal anything. Each time there was an improvement, Duquesne had it shortly thereafter. You've got a world of thieves. Anyone who's got one of these things is king of the world. Okay, assume you don't need a receiver. You've got a transmitter that'll put anything you like anywhere. Now you can bomb any place there is. You can drop a bomb anywhere. Anybody remember a story called The Person from Porlock? Okay. Who? Oh, yeah, one of the early ones. One of the best, too. That was a good one. I'd forgotten that. The result of that is that you wind up either with a permanent tyranny if only one group has this object and if they can agree on it, if they can stay in agreement with each other, or you get so many bombs falling that society gets blasted back to before you've got this transmitter, this receiverless transmitter. And this could happen any number of times, I suppose. Assume you need both a receiver and a transmitter. Most stories will assume this because otherwise you don't get a society, really. You get a short war. Okay, assume you need it. You've got booths. You walk into a booth, you dial. You put a coin in, you dial. You put a slug in, you dial. You put a slug in, it takes you straight to police headquarters. With this, everything becomes obsolete. Freeways, cars, airliners, the whole bit. What do you do with an entire set of freeways and no cars, no buses?
Drag race. Use them for bicycle riding.
Yeah, you use them for drag races, some parts of them. You put houses on other of these freeways. Some of them you turn into parks. You cover them with dirt.
What are you going to do with these things if two people get into the same booth at once?
That's their business, I would say.
What happens if Superman used to change his identity?
I don't know. If he's a friend of yours, is Superman out in the audience? I guess we never will find out. Oh, there he is. Yeah. What does happen if Superman changes his clothes in a teleport booth?
Well, you see, his clothes stay where they are, and he teleports. There's a very embarrassed Superman.
Now you know.
Super attributes.
I said that any assumption on limitations would give you a different society. Right. Freeways, cars, airliners, any of these may or may not become obsolete depending on the cost of transmission. That is, what kind of coin you drop in. It may have to be solid gold and that big across. If it's that big, you wouldn't want to use teleportation to get anywhere closer than Moscow, say. If the cost is high, you'll still want cars, motor scooters, freeways, etc. If the cost is low, but there's a limit on distance, the first thing that's going to go is airliners and ocean liners too. Oops, sorry, I got that wrong. The last thing to go is airliners if there's a distance limitation, because you'd have to do it in jaunts. Maybe 12 different jumps to take you across country. Relay satellites? There again, you run into conservation of momentum and conservation of energy. It turns out that if you teleport a mile upward, the temperature of your body should drop 7 degrees. And downward it should go up 7 degrees, which is even worse.
Would you have to be modulated on a carrier of some sort of?
I don't know. I've been assuming teletransposition. I don't like turning a man into a beamed signal and beaming him across space. I've been assuming some sort of twist, some sort of jump in space. But once I assume that, I do run up against these conservation problems. I wrote a story on that once, by mind alone. That dealt with psychic teleportation, but the same thing would be true of your machinery. You'd have to compensate for it some way, if you could, and if you couldn't, you would be going in jumps. If you wanted to teleport up to a relay satellite, you'd have to be prepared to heat up the body once it arrived. Where am I? Yeah, if your distance is limited to miles or tens of miles, then your freeways are obsolete, but your airliners aren't. If your cost is high but the distance unlimited on the surface of a planet, your airliners go. That distance limitation does look good. It looks like you'd have a distance limitation no matter what happened. If you've got conservation of velocity, you'd have to go around the Earth's curvature in jumps, or otherwise you'd wind up at your receiver with a fairly dangerous velocity. If you'll believe that, you'll believe anything. Yeah. You'd have to do all of this in small jumps if conservation of velocity holds. Okay, let's make an assumption. You've got a transmitter about this size. I can hang it from my belt. My receiver is bigger. It's an open platform. It could be a public platform the size of any good-sized public square. These are public receivers, or it could be a small plate at home. This is cheap, easy teleportation. And what you get with that is Alfred Bester's "The Star's My Destination" again, with a few changes.
One more thing. The only way you're going to be able to teleport, you're actually really going to look at all of the considerations. The ones that are going to be able to teleport, the ones that
Okay, now start over.
The only way you're going to teleport at all, if you really want to consider all the implications of it, the only people who can teleport are the ones who own spaceships. Because if you try to teleport from an atmosphere into atmosphere, you're going to wind up having your body in the same place as the molecules of the air. You're going to be there anymore.
That's why I usually assume booths. You got a transmitter booth with you in it, and it's also full of air. The receiver booth is a vacuum. You teleport yourself and the air. Teleport them back and forth? Okay, that'll work too. It's your choice if you're going to go and build it. Yeah.
Are you assuming an instantaneous?
Yes, I'm assuming instantaneous.
Does that work in a relative universe?
Maybe not. In that case, I'll assume light speed. On the surface of the Earth, it doesn't particularly matter. You can circle the Earth in a seventh of a second moving at light speed. And that's a 14th of a second for anywhere you're likely to go, because you take the short part of a great circle. 14th of a second just isn't worth worrying about.
What do you do if you change your mind halfway through a flight?
You don't have time. Don't worry about it. Oh, yeah. I don't know. I think about hyperspace differently. I just noticed something I wrote down and then forgot. If you teleport between worlds, from one planet to another, the conservation of energy and momentum won't hold for Poole-Anderson type beaming. That is, recording a human being and beaming the signal across space. It won't matter, except that you get a red shift or a violet shift. Either way, you'd have to worry about that. It might change the signal. Okay, you've been wondering why I had the blackboard. I've got 3 reasons. Well, can that be done? Good. Let's talk about how you experiment with teleportation once you've got something that does teleport. We'll assume it like this. A booth of some kind. Here's your first setup. Two booths. You put your object here and teleport it to here. That's obvious enough. Okay, I drew them too high. Let's draw it low. These are up in the mountains somewhere where you've got your secret base. They're up in the mountains somewhere where you've got your secret base. You build your third set down here. Oops. Cruddy chalk. You build your third set down here to check for conservation of energy. You lose potential energy teleporting down to here, so you'd expect a rise in temperature. You build your fourth set on railroad tracks, so you can check for conservation of momentum. Your fifth and sixth sets, well, you alter these because it's cheaper. You build a door in each of these, and you got your scientist. Let's build them a little differently. Let's build our doors here, and here, and put our scientist here. I can't draw very well. The guy's got a gun. He wants to check how fast he can do his teleporting. He fires a bullet through this door, and if he's wrong, if it doesn't shoot that fast, he's going to put a little hole in his machine costing about $1 million. See? But if it does teleport just as fast as he expects it to, the bullet's going to hit him right in the back of the neck, costing much less.
Put a hole in the other little machine.
It'll come out this door.
Oh, I see.
It'll come out this door, and it won't re-enter here because he's in the way. See? It's all thought out, believe me. What?
You won't have any life insurance.
Well, we can pad the guy's back is what we'll do. You know what'll happen? Okay, we put some padding in here just in case. Then we set the teleport. The padding teleports to here. The bullet goes in here, doesn't teleport fast enough, and puts a hole in the booth. See?
Maybe instead of a bullet, you have a long thread of lead, like a focal plane shutter. The thing scans. Right.
Hey, how about a crossbow? A narrow lead crossbow. And they find out how fast the thing teleports by how much of the arrow gets teleported to here. Some of it comes out and hits the guy in the back, and the rest of it puts a hole in the booth.
What are the Supermen doing?
We'll ask the good doctor later. Like I said, you get some strange assumptions. You get a different kind of society every time you assume a limitation. Let's talk about spacecraft for a minute. Here's a colony spacecraft, assuming that you need both a transmitter and a receiver, and assuming that conservation holds of velocity and momentum. Bye. Okay. Okay, you'll tell me the significance if I draw one by accident, will you? I'd hate to miss a joke. Okay, what we've got is a couple of rocket motors here, as much fuel as you can hold in here, and a teleportation cage here, open-ended. Can you see it? You may or may not have a manned craft. You won't have a manned craft if teleportation is instantaneous, because you won't need it. You set this thing off from Earth and fire it wherever you want to go. Say we fire it toward the galactic core. That's easy. There's more traffic in that direction, for one thing. You fire it toward the galactic core, rockets going here, and you keep it firing until the fuel runs out. We assume we can pack a lot of fuel either in here or as ice around here, and I know who thought that up first, and it was you. Packing ice as fuel around a spaceship hull. This is the easy way. The Martian way too. Okay, you fire it until the fuel runs out, and then it coasts in the direction of the galactic core. It comes to a star system, goes through, and assume it's a star system the size of the solar system. Then you got 10 hours to shove spacecraft and colony building materials into your transmitter, and they'll come out the receiver at rest with respect to the system. But they'll trail all across the system if you take 10 hours at it. The faster you can shove them in, the closer together they'll come out. Some of them will be ships designed for moving around in space. That is, they'll be mostly attitude jets and claws for handling material. Some of what you'll shove in is material for building another receiver. In fact, you may just send through a few ships to put it together and the parts of the receiver. You put that receiver together and you get the rest of your colony shoved through there, and now you've got a system colonized. Furthermore, this thing is still going toward the core at its same speed. You never use another drop of fuel. You just let it coast, and whenever it comes towards something that looks interesting, you shove another colony through your transmitter. If you're warlike, you shove a bunch of warships through and draw yourself a line of warships all across a system to conquer it.
Why bother to use fuel at all if you've got a teleportation device and relative velocity holes? You take one element of the thing and you drop it onto the surface of a gas giant and have the other element feeding into your reaction chamber. And then turn it on. The gas that's going to come out is going to expand. You're going to have all of this pressure, and you're going to have an everlasting rocket until the gas giant runs through.
You're right. There's your system. This is a receiver. This is a receiver. Your transmitter has been dropped onto Jupiter, and it's all free. Okay, that's one ship. Here's another ship. And let me define my assumptions for this, and let me find my assumptions for this. Yeah. Okay, here's the assumptions for this ship. One, there's a limit on the distance of teleportation depending on the curvature of space. The more curved space is, that is, the closer you are to a big chunk of mass, the shorter the distance is going to be. On Earth, the distance might be 2 feet. Around the orbit of Mars, it might be miles. Might not, I don't know. Beyond that distance, what you send into the transmitter will come out of the receiver as fluid, as dust. It'll get all torn up by the curvature. Okay, we make that assumption. We can still get a good method of transportation. I'm drawing this a little strangely, and I don't really care how I draw it. The point is that this ship will teleport onto its own front end. Push the button. We'll draw a button in here. I've never used this in a story because I've never had the nerve. You push this button, and the ship teleports itself out to here. See? Teleports itself out to here. But if you hold the button down, it goes in a steady stream of images, because once it's here, it wants to teleport to here, and you're still holding the button down. Notice that there's no limit on its speed, because you're not doing anything with its velocity. All you're doing is changing its position. So there's no relativistic. So there's none of this nonsense about relativity.
Fall off the edge of the universe.
Don't scare me like that. That's a mere soup.
Stop pushing the button.
Well, we assume some kind of limit on the speed, but it isn't a relativistic limit.
Electronic relay.
Also, notice that the longer the ship is, the faster it's going to go. But the longer the ship is, the more limit you put on how close it can get to a mass. 2. It'd have to be 2 feet long or less before you could bring it down to the surface of the Earth. And there you got problems of the same type you ran up against in the Lensman series. When you turn off the thing, what velocity have you got?
If it's a perfect copy, how do you turn it off? You can't move your finger off the button.
Sure you can. You're a perfect copy, too. You've got free will. Well, okay, I don't know. That's a problem for you engineers out there. Yeah?
What happens if something gets in the way of that ship?
I'm glad you asked me that. Let me tell you some of the things that are going to get in its way. One, light is going to get in the way. Notice that a light beam crossing through here, this empty space, is going to be suddenly inside the ship. The result is that everything on the ship is going to be transparent. The further away it is, the more transparent it is. You're going to need no windows at all, because the walls will be so far away that you can see straight through them. They'll be like glass. You can barely tell they're there. Your hand may be a little more opaque. That's one thing that's going to get in the way. Another is dust, and a little dust is going to get picked up in the ship and carried along. Some of that dust is going to be in your body, so no matter what you do, you're going to need medical attention by the time you reach your destination. Another is hydrogen. There's a lot of hydrogen out there, and it's going to get picked up, and so aboard this ship, there's definitely, absolutely no smoking whatever. As for meteors, look, here's what we do. First, I'm drawing that too low, aren't I? Nobody's going to be able to see it. Here, we got the sun, the Earth. We take the ship from Earth, bring it to the sun with the nose pointing outward. This is the direction we want to go. We bring the thing in toward the sun and keep it there a while the ship falls toward the sun. We let it fall backward toward the sun for a while, and then off we go. We got a relay set up here so that if the thing bumps a rock of some sort, the ship immediately goes off, and the rock isn't going to do it any harm because the ship is moving backward at a hell of a clip. All right?
There's a much simpler solution for all this. Put another teleport system that moves things from the front of the ship to the back to get them out of the way. You can go right through.
You really think that's simpler? I thought my solution was a lot more elegant than that.
This could be a tunneling machine that would go right through a planet or a star if it's in your way.
That's true. Or even if it wasn't, if you happen to dig tunneling.
Just teleport things into
Let's forget teleportation. Stay with the good old ram scoop.
Yeah, I like the ram scoop myself.
Well, you wrote about it.
Yeah.
In the potential energy problem, why do you assume that the energy's going to show up as heat?
Well, it can show up as other things. As a matter of fact, I've been assuming that if you teleport downhill, the first thing you're going to get is a jump outward in the electron orbits. You'll get some sort of energy, and it'll be a jump in the from an inner orbit to an outer orbit. The electrons will then fall back, presumably, and give you heat. Energy coming out somewhere in your body to heat up the rest of it. This is what I've been assuming, but make any assumption you like that looks good to you. There's got to be energy, and the simplest, most random form of energy is heat.
What happens when you go through a nice region of gravitational collapse like a neutron star?
I don't go through a neutron star. This kind of thing scares me.
Don't dare.
If anybody else wants to take over, this has been an exercise in speculation, an exercise in writing off the top of your head. All first draft. If anyone wants to handle it, fine. Some of the ideas belong to other writers. Some come from me, but I state that I have no market on it. Anyone who wants to write the story, go ahead. Anyone who's got the nerve to deal with this thing, why, go ahead.